Well, my name is Raju Gulabani, and I am responsible for our databases, analytics, and machine learning services, which Andy talked a lot about yesterday. I don't know if you made it to the reInvent keynote yesterday morning or not, but he talked a lot about it. I'm excited to be involved in these services. I've been doing it for about 8 years. And I think because of the impact these technologies are having on your business, on the users that you serve, I'm lucky to be doing what I do because it's exciting to be able to impact in positive ways people's lives and help you transform your business. And I'm going to take the next 60 minutes to talk to you about our database analytics strategy. And I'm going to, since I've been here for about 8 years and I've had the fortune to be involved in all these services from the very beginning when we were conceiving them, I'm also going to give you a little bit of the story behind the story, if you will, so that you can not only understand what we offer, what you should use when, but also give you a sense of why we built them, and that will probably give you a little more understanding of what we're trying to achieve. I'll give you a sense of the scale at which these services are used, because we have more customers using it in our cloud than probably all the other clouds have customers combined for anything. And then this will give you comfort that you're not going to be the first customer using these services in scale. I have customers like Airbnb who probably wouldn't exist in the form they do if it wasn't for the AWS cloud and for the services that I'm going to talk about. Give you lots of sense of the use cases so you can see the way other customers are using these services. It'll give you maybe a roadmap for where you should use and how you should use these services. And in the end, my goal is that when you go back from reInvent next week and when you look at what your most important priority is, it would be to take all your databases that are not yet in the AWS cloud, all the data that is probably not in the AWS cloud, move that all to us so that you can get value from all these services that I'm going to talk about. OK, let's talk a little bit about strategy. So when we started in 2010 to build the portfolio that we have today, we looked at what our market share was at that point and how many customers we had. And we, at that time, had just launched Amazon RDS first version, which just had MySQL in it. It had been out for a few months. So we had a few thousand customers. I think I had a total of $0 billion in revenue at that time. And most of the database business was on-premise. It was really dominated by 3 companies, Oracle, Microsoft, and IBM. And if you look at the strategy at the time, they each offered one database, which was like an all-singing, all-dancing database for all your workloads, whether they were data warehouse, analytics, databases, and so on. And I think these beasts were complex enough that you were happy that they weren't wanting you to learn and manage 2 or 3 of these. But since there was one database for all use cases, maybe it was OK at that time because you weren't working with the kind of data sizes you're working with today, the number of users you're working with, and everything is in life getting faster. Everybody wants things done quicker. So maybe it was OK. But we envisioned that when we go to the cloud and design the database not for the last 30 years, but for the next 30 years, maybe we should take a different approach. And the fundamental approach in which we are different than every other provider is that we have built a set of services that are purpose-built or designed to be optimal for certain use cases which we think you would be using a lot. So we have multiple services. So one's all-singing, all-dancing database. And I think the benefit that you would get from that approach is that you would get higher availability, higher durability, lower cost, better performance. And in the end, if you think about all the folks in the IT industry and all the reasons why we all lose sleep, there are probably 3 major causes for it. One is obviously power fails and servers go down. Second is network causes you trouble. And probably the third is that the database gives you a hiccup. Either goes down, isn't available, isn't performing on Monday morning as you thought it should. And there's a lot of lost sleep in the IT industry which can be contributed to the databases. And my goal is that if you use our services, you'll sleep better, live longer, and be happier. Now, the other thing that is different about our strategy is that we have designed our services with 2 things in mind. One is that a number of workloads are going to be coming to us from on-premise applications. And they would be tied to whatever database they are used to. We want to give you a diversity of database choices so that when you bring your applications to AWS, you have to do the least amount of changes if that's what you want to do. The second or the third thing that we have as a core part of our strategy is that we have leveraged the architecture of the cloud, because we have designed a lot of these new services to be used in the cloud, in the AWS cloud. So we don't have to have the lowest common denominator in terms of how can you make it work with a single server on-premise, et cetera. We have designed these services to take advantage of the AWS architecture, and you'll get better scale, performance, availability, and all of that. And I will speak to that as we go through it. So fundamentally, a different strategy. And let me just walk you through quickly with the number of services we have and how you would use them. I'll just build this chart quickly. At the very bottom of this chart is the most important thing, which is how do I get my data from the databases that are running on-premise to AWS. And we give you a variety of choices, starting with a very appropriately named database migration service, which is for migrating databases from on-premise to us, and I'll talk more about it, as well as probably the coolest way, in my opinion, that you could do it is using Snowmobile, which we introduced last year at reInvent. It's an 18-wheeler truck, which we will give you, or the right term is probably not ship it, but drive it with a security guard to your data center. Leave it there for maybe a month, 3 months, 6 months, however long you need. You can plug it into your network, download all the data that you want to give to us, which may be in petabytes with an 18-wheeler. And then we'll drive it back with security guards and get it over to the AWS cloud. Turns out, trucks are the fastest, highest throughput way of moving data. And so you can do that if you want. You can also do it in real time using Kinesis. And once you land your data in S3, that's where we come into play. And then we give you different kinds of services for different use cases. So obviously, for the last 30 years, the most popular database architecture has been relational databases, although early in my career, I worked on prime mini computers on network and other architectures before relational became very popular. But we give you 2 services, and I'll speak to them. RDS is our most mature service, came out in October of 2009. And Aurora is a fastest growing service, which has been used by customers for about 2 years. If you're interested in highly scalable databases and you have a need for scale which cannot be served with relational databases, for that we invented at Amazon in 2004, the whole notion of NoSQL databases with Dynamo DB. In fact, in 2004, we wrote a seminal paper called the famous Dynamo paper, which this year got awarded by ACM as Hall of the Fame award, which is given to papers that over 10 years have had industry impact of massive impact on the industry. So we have NoSQL services, which are for scalable data use cases. And then, of course, we have a number of services for analytics. And I'll walk through some of these as I go through over the next 50 minutes or so. But the point that I want to make here is that we have designed for all imaginable use cases for you, purpose-built database services which are optimal for those use cases. And this strategy actually is working for us, as I will speak to you. So there is a broad set of services, and it's also something that we've been working on for the last 8 or 9 years. So we have done a lot of innovation, and these are very mature services. So just give you a sense, this year, including the launches that we have done at reInvent, we would have done 6 major new services and 210 features just this year. And if you look at the last couple of years, the pace is just going up. And in the last 3 years, we have done something like 460 features and major service releases to maintain the depth of the portfolio along with the breadth. So you will get very mature services for every imaginable use case that you can use to serve your users and your use cases. And this strategy is working because we have more customers, in hundreds of thousands of customers, using these services. So just give you an example of a few of them. They're in every imaginable vertical in an enterprise. They have startups, the sizes of various kinds, companies of various sizes. So companies like Netflix use us quite a bit. GE is moving a lot of their databases. In fact, they have said publicly they're moving all their data centers to us over the next few years and would have very few data centers left that they run themselves. I mentioned Airbnb, which wouldn't have been possible but for the fact that we have these services. Companies like Redfin use us, Lyft use us, Capital One, many, many other companies are using a variety of these services. In many cases, they're using multiple services inside a single application to make sure that they get the right architecture and the right characteristics that the applications need. And the folks who track the vendors in the market to see who's doing how well and how the revenues for these various services are and various players are, how well they are loved by their customers, and so on. You know, if you look at Gartner and look at Forrester, who do this on a regular basis, Forrester just came out with a report where they said that we are now the #1 player when you look at cloud databases, significantly ahead from revenue, from users, from references they do with customers, and every other metric that you can look at to assure that you're using a database provider that is going to give you the best technology for your use cases. We are the #1. In fact, if you look at Gartner's approach to looking at it, they combine the cloud as well as the on-premise database. And of course, the players who've been in the on-premise space, like Oracle and Microsoft, have been doing it for probably 30 years now. And even if you take the weight of the last 30 years and all the install base they have, they still place us right behind those two players, even though we just play in the cloud and in the AWS cloud space. So that tells you a sense of scale at which we operate, and we think we have the best technology and the most users, and we are the most customer obsessed to make sure that we serve you the best. Let me just quickly run through each of the areas where there are various services, and I'll highlight them in terms of when you should use which services and what are some of the use cases that people are using in specifics. So in the relational database space, as I mentioned, we have two services. RDS is a service which came out in October of 2009. And we originally started by managing MySQL databases. And the basic idea behind RDS is, if there's only one thing that you remember from my presentation, it is that if you have a relational database, you want to use it on AWS, best way to do it, probably the only way you should do it, is to use RDS. And the whole idea behind RDS is it's a managed service which takes away all the muck, as we like to say, from having to deal with configuring databases, patching databases, keeping them available, et cetera, so that you can focus on where you add value in your application and not have to worry about keeping these databases patched, updated, backed up, and available. And since 2009, we have added every major database engine or server that you may be interested in, depending on what your application needs. You know, we run Oracle SQL Server as the old guard commercial databases that people use because they have these applications that they're bringing from on-premise use cases. And of course, open source is becoming increasingly popular, and we support MySQL, Postgres, MariaDB there. And Aurora is our own that I'll talk to a little bit more, and it was spoken to at length yesterday morning. One of the key features, which is probably the defining feature that you can't do using your own DBs as easily, is what we call multi-AZ, which is a highly available architecture for databases. And what we do is, with a single click in our console for configuring databases, you can ask us to give you what we would call as a multi-AZ configuration of a database. And what that does is it uses multiple data centers that we call availability zones in a single region. So let's say if you're in the East Coast region or the West Coast region, we will have multiple data centers that are separated by distance enough, by a few miles from each other, so that they are flood zone separated, power separated, and not go down at the same time. But they have latencies of 2 to 5 milliseconds, so that from an application and database perspective, they're really next to each other. And what we do when you ask for a multi-AZ database is that we give you a database where there's a master in a single AZ, and there's a standby replica, which we keep synchronously replicated behind the scenes between these data centers. And we detect failures at a hardware level, at a software level, at the AZ level. No matter what happens in an AZ, we will detect it. We'll fail over your database to take the standby and make it a master. If your application is doing retries, it'll see a failure. Within 30 seconds, the database will be back. And this is something that even if you, in the old days, were a large company, you probably didn't have data centers in all parts of the world, multiple data centers in every region, so that you could do this. Of course, if you're a small company, this was something impossible. And this is one of the reasons why production databases people run as multi-AZ. So the goal should be, if you have a database, run it on RDS. If it's a production database, run it on multi-AZ. And the other point I want to make is we will talk a lot about Aurora, but we have a lot of customers running good old commercial databases, Oracle, SQL Server. We probably run more Oracle databases in the cloud, our cloud, than Oracle does in theirs, and same thing is true with SQL Server relative to Azure. And there are companies like Intuit, GE, Verizon, Vodafone, NASDAQ, Johnson & Johnson, Merck, so on, that use our commercial databases under RDS. So it's something we do. We are customer obsessed. We want to serve you for the things that you want to do. We'll give you choices. We'll give you recommendations. But at the end of the day, we will serve you with whatever you need. Let me talk quickly about the transition that we are seeing from these databases on the commercial side to open source. Obviously, these commercial databases are quite expensive. Software business, the way these guys have done it is a beautiful business, has 95% gross margin, which turns into expensive cost for you. And I used to say that that business is probably better than being in the drug business because it has higher margins and lower risks than anything else you could do. But it turns into expenses for you when you have to deal with databases. And of course, these are proprietary databases, so there's a lock-in that goes with them. And in many cases, they have punitive licensing terms. They'll let you use whatever you want, but then they will come and audit you, and you'll end up with a significant cost because of the way they audit you. So because of these reasons, people are moving to open source. Of course, there are other reasons as well. And that's why we've seen a significant growth in people using these open source databases for mission-critical applications. Of course, customers still wish for commercial-grade performance and availability because, after all, you're running mission-critical applications. And we had been hearing from the very beginning in 2009 that, hey, can you guys enhance these open source databases so that I can get the enterprise-grade performance and reliability that I'm used to from these expensive old guard databases? And that's exactly what we did. And Aurora was a product, was a service that we started working on and conceiving and thinking about in 2010. In fact, I had my first conversation with Jeff Bezos about it in 2010. He said, how long do you think it'll take you to do it? And of course, I didn't have a very large team at that time. And I said, probably 2 years. And he laughed at me and said, well, I think it might take you longer, so just get started quickly because these things can take a bit. And that's when we got started, and we launched the service. He was right. It took me 5 years. And we launched the service in 2015, and it's grown like crazy since then. The reason is that we are giving you best of both the worlds. We're giving you the commercial-grade performance, availability, and features at open source-like prices. So it saves you 1/10 the cost from a total cost of ownership from running those old guard databases to moving on Aurora. And give you performance which is significantly better. For example, if you compare the MySQL version of Aurora with the stock MySQL Community Edition 5.6 or 5.7, you will find that we do 5x the throughput of a stock MySQL. So on our biggest instance today that we offer is a R4 16XL, on which we can let you do 200,000 writes a second and 600,000 reads a second. Those are big numbers. And you have to have a significant workload to be able to consume that kind of a throughput. But it's 5x of what you would get with MySQL on Postgres, which is basically a better design database. We do as good as 3x compared to what your stock Postgres would do. We have designed a completely new storage service underneath it, which is designed for database workloads. It's optimized to give you better throughput and better availability. Just to give you a quick example, when you would do a write on this database, this is obviously a MySQL compatible database, so your application doesn't change in any way. When you do a write, behind the scenes, we take that write and we write it to 6 different copies because we are scared that we might lose the data for you. So we make 6 copies. In fact, we make 2 copies in every availability zone so that there's no chance of having any durability issues. And we also give you higher availability because not only can you have a master, but you can have up to 15 read replicas, which can be in either the same availability zone or other availability zones. And these read replicas can act as failover target. Just like I explained multi-AZ earlier, these read replicas can act as your standby, if you will, for multi-AZ. So if your master fails, we detect it and we fail over to read replica. And you can set up 15 read replicas in sequence if you want to. So if the read replica fails, it goes to the next one and so on. So it gives you high availability. It's designed for 99.99% availability. And the other thing that is very nice about it is because it has this shared storage architecture, we don't do replication at the database level. We do it at the storage level. What that does is that it really doesn't put any load on your master when we're doing the replication because it's happening behind the scene on this distributed storage system. And it also makes the lag between the master and the read replica much smaller. So it's hundreds of milliseconds instead of seconds. And it just makes it give you much better experience. And yesterday we announced availability of a feature that a lot of you were asking us for the last few years. It's called the Multimaster single region feature. Now, the basic idea here is that just like we do the read replicas going into different AZs and scale them out, but we limit you to a single master with 200,000 writes, we will now be able to scale your write workloads and give you multiple masters in different availability zones. And this is the only MySQL Postgres compatible database service which does that with multiple availability zones. And there are two reasons why you would want to do it. Probably the most important reason is that many customers ask us for availability that is greater than 30 seconds failover time. They don't even want to have a 30-second hiccup on their application. And because of this reason, the way this architecture works, even if a master fails within 100 milliseconds, which is, in the application world is going to be instantaneous, your application is working with the new master, which has all access to all the data. And the other reason is that if you have performance and throughput needs for your application where you need to go beyond 200,000 writes a second, now this will allow you to go to multiple masters and scale up from there. So we're taking preview. It's opened up as of yesterday. We're taking a signups for this so that we can give access to you guys. And we are also working on a multi-master, multi-region version of this, which is going to be sometime next year. So there's a lot going on. Of course, this is going to help you with all of your workloads where you need massive scale, massive availability. You can't take a hiccup. These are probably your most critical, mission-critical applications. But you also probably have workloads which are going to be much lower in terms of requirements, where you probably are more cost-conscious. For example, you might have dev and test workloads where you don't need to have them up and running all the time. Maybe your developers use them from 8 to 6 or 8 to 5, or if they might, like my developers, maybe 8 to 9, 8 a.m. to 9 p.m., whatever the time frame is, certainly not 24/7, certainly not weekends all the time. So in those cases, we are introducing a new version that Andy talked about yesterday called Aurora Serverless, which is also going into preview. Here, the basic idea is for those workloads, which probably tend to be on the lower end of your spectrum of usage, where you don't need the database to be on 24/7, and it's more of a variable workload, you would save from both a cost perspective and manageability will be much easier because there's no servers to set up, there's no instances to think about. You simply come to us and say, give me an endpoint, and we'll pretend for your application as if you have a database. And then when the application starts doing requests, then we'll spin up the database in 5 seconds or less and start taking traffic. And when the traffic goes down, with a timeout that you specify, we'll take the database down, leave the stuff in the storage so that you're just paying for storage and not for compute. And this would be useful for workloads, as I mentioned, like dev and test. You might also offer a blog, which doesn't get a lot of traffic. For example, maybe my blog, nobody wants to see what I'm saying. Maybe they look at it once in a while. And I don't want to pay for a database all the time. Or you may have applications which are more cyclical in nature. Maybe you have a financial application that gets a lot of traffic end of the quarter. Maybe you have an HR application that gets used during the review cycle more. But otherwise, it just sits there and doesn't really need that much. So we'll scale up and scale down as needed. So there's quite a bit of innovation that is happening in the space from us to give you different kinds of, serve different kinds of use cases. And of course, as I mentioned earlier, Aurora is the fastest growing service. It has tens of thousands of companies using it now. Companies like Samsung, NASDAQ, and many others that are depending on it to do their mission critical workloads. So it's something that you should be comfortable in using for your production workloads. It's going to give you the best performance, the lowest cost of any of the MySQL or Postgres compatible solutions. And in fact, people have been migrating to us quite a lot over the last few years. And in fact, as I mentioned at the beginning, We're making it easier because, all this technology is great, but if you can't bring your database easily to us, that is not as interesting. And customers want from us a way to bring their databases where the failover time or the time to cut over from on-premise to the cloud is minimized. So we have this service called Database Migration Service. It's actually a two-way replication service. What it does is you spin up a database in the AWS cloud in RDS or EC2. You connect it to the database, which is running on-premise. We'll keep the two databases in sync, and when you're ready to fail over, you can simply fail over in a few minutes. Your master will be running in AWS. And this technology allows you to go like to like, so you can go from Oracle in on-premise, God forbid, to Oracle in AWS. But if that's what you want, we will do that. Or you may want to go from Oracle SQL Server to MySQL Postgres. So it's like to unlike. We also have a service which we have a very friendly name again called Schema Conversion Tool. And it's actually a little narrow name than what it actually does. It's something you can use to convert your schemas, PL SQL code, from going from Oracle SQL Server to MySQL, Aurora, Postgres Aurora, and so on. And we will convert from PL SQL to PG SQL. We get roughly 80% of it right, which reduces your effort required for migrating these databases. And the rest of it we'll point out wherever we couldn't convert either your application code or your PL SQL code or your schema, and then you can go manually do it. We can also offer you professional services, and we have a set of partners that will work with you to make sure that they help you with that as well. And we have, we migrate hundreds of databases every day, and we are now up to 45,000 databases that we have migrated using this service over the last 2 years that the service has been in existence. And lots of customers are doing it. Here are some names of customers that are doing it for mission-critical applications. And I'll give you a couple of brave souls that have been willing to say on the record that they're moving off of Oracle to go to Aurora, like this company called DHI, which has migrated their databases to Aurora. And another big company that we spoke to yesterday we spoke about it in some other sessions I was doing. FINRA is a very large company. It's the regulator for all stock transactions. They deal with 20 petabytes of data that they look at to make sure there are no insider trading happening on any of the stock exchanges. They look at 75 billion transactions a day, stock transactions a day, and probably looks like today might be a busy day for them. And these guys used to be an Oracle shop, and they are in the process of moving to RDS Postgres. And now that we have put Aurora Postgres in general availability a few months ago, they are in the process of moving to Aurora Postgres as well. And here's a third customer, which is Expedia. They were in Andy's keynote yesterday. Expedia started as a division of Microsoft back in '96 when I actually used to work at Microsoft as well. And they spun out as a public company, so they are historically been a Windows SQL Server shop, and they are all in on AWS, moving everything to us. And they were one of our early customers to move their workloads to our databases. Aurora as one example, and in this example, they also move a lot of their workloads to Redshift that I'll talk about. Let me quickly run through our NoSQL set of services, and I'll start with Dynamo DB. As I mentioned, this is a service that we launched in 2012, but it is based on all the learnings and all the technology that we created going back to 2004 when Werner Vogels, who did the keynote today, who's our CTO, wrote a paper called the Dynamo paper, which is the famous paper, and we were just inducted into Hall of Fame. And the thing that happened to us in 2004, just to give you a little bit of history as to why we did this technology, is in 2004, we were probably one of the biggest Oracle database shops. And we ran our e-commerce business, which was, I think, a $2.3 billion business, if I remember the numbers correctly. And we ran it on an Oracle rack, of all things, in OLTP. We didn't know any better. And there was some problem that happened and brought down our site during Christmas. One of the busiest time for online retailer, and we were down for over a day. And we must have lost, even at that point, a few $1 million. So Jeff talked to Werner and said, you got to do better. And then he did. He wrote the paper, and some of those folks that were working with him at that time were the ones who worked with me to create this product called Dynamo DB, which we launched in 2012. Our goal was very simple. We're not for everybody, but we are for those folks that need massive scale like Amazon.com, which, in this connected world, even startups need that kind of scale very, very quickly. And the idea is that if you need a database that has no concept of limits in terms of scalability, either on size of the database or size of, or the number of transactions or requests per second that you want to do, then this is the guy that you would use. In fact, customers move to it when they have tried everything else and it doesn't work for them, they move to Dynamo DB. And I'll speak more to that here in a few minutes. So as I mentioned, it's a highly scalable database. The other thing that is unique about it is that we have constrained the feature set. So it's not SQL compatible. That's why the name NoSQL. And we have constrained the feature set to make sure that it serves 3 tenets above everything else. The first, as I said, is scalable. You can create a table, start writing to it. It might be a 1 gig table, and it could seamlessly grow to, one of our largest customers has a single table that's a 400 terabyte table. It just grows to that. You don't have to say, please give me 400 terabytes, I might need it. You just keep writing to it. And behind the scenes, it'll deal with it. So its first tenet is unlimited scale. Second tenet is predictable fast performance. So reads predictably done in single-digit milliseconds. And if you think that's too slow for you, we have an option called DAX, which is an accelerator, a transparent accelerator that can give you microsecond, hundreds of microseconds of reads. But it's predictable performance for reads and writes and highly available. So every write is written to 3 copies in 3 availability zones, and we make sure that there's no failure. So this is basically a multi-master single region system. You can ask us to do 100 reads and writes if you're testing, and then you can say, I'm done testing. I'm going to be using this for Oscars because my app is really popular during Oscars or Super Bowl or whatever. In fact, customers do that. And you can call an API and say to us, hey, please go from 100 reads and writes a second to 1 million reads and writes a second. And we'll say, please give us 20 minutes. 20 minutes later, the system would be at 1 million reads and writes. And for those 20 minutes, we'll continue to give you what we had promised, which is 100 writes and reads. And when you're done with Super Bowl 4 hours later, you can come back to us and say, I don't want to spend any more money. Dial it back, and we'll dial it down. So it's a pretty cool, magical kind of a product, which people use for massive scale. And we have launched a number of features. The biggest feature was the one that we talked about yesterday, which is going into GA as of yesterday at, I think, 1 p.m. We turned it on right after reInvent keynote. And basic idea is this is a global table, which is a global multi-master, multi-region database available for production use case as of right now. And the idea is that you create a table, and you just say to us which are the regions in which you would like your data to be replicated. And we'll do that all behind the scenes. You could say it's on US East, US West, our Asia data centers, our European data centers, multiple of these. And we'll take care of it. And the basic use case that people are asking for is they have these applications that have a global user base where you may be a hotels or airline reservation site like Expedia, and you are being used by multiple users that travel, and they want to get low latency access to Expedia, whether they are primarily in US, maybe in New York, or go to London, or go to Bombay, or Mumbai, or any other place. And the basic idea here is behind the scenes, we replicate the data for you so that you get a local performance for your users and applications without having to do any work in your application. It also gives you, as Werner was saying this morning, it helps you design your applications for 5 nines, because even in the unlikely event, which doesn't happen, knock on wood, a single region is out. You don't have to worry about it because your application can fail over if you design your application to do that. But certainly, we're giving you building blocks at the, at the database level to do that. So it's a pretty cool service with this feature. And we also came up with a feature that was in request for a long time. It's a very simple feature at a high level, backup and restore, but it's a hard technology because we're dealing with 400 terabyte tables that we want to back up and restore. We want to do them quickly without impacting your application. So this is also going into GA, where you can click a button on the console, and within 60 seconds, we'll back up however big your table is. If it's a 400 terabyte table, that's fine too. And then you can come back and restore it. And then in Q1, early Q1, we will give you what is known as point-in-time restore, where in case you're dealing with not requiring your database backup to be kept for compliance reasons for years, but you just want to deal with application and user errors where you've made a logical corruption to your database, you want to roll back, you can do that using point-in-time restore. We will let you restore to the minute before your request. And we automatically will give you 35 days of backup if you turn on this feature. All right, so there's quite a few cool features. It's being used at massive scale. I'll just speak to 2 customers. One is Samsung, which obviously everybody's familiar with. They use it for some of their mobile applications. The amount of data they store in S3, which is basically in AWS, is 300 petabytes. And all of the data that they store, which tends to be in some cases metadata for that data or other use cases, about 850 terabytes of data in Dynamo DB. And they do 130 million API requests a day. And these guys migrated from Cassandra because at that scale, managing Cassandra gets to be a hard problem. And the nice thing that happened to them is that saved 70% of their cost by moving to us and got a better product. And as you can see, I'm not born in the US, but I've lived in the US for about 30, 35 years. And when I came to the US as a young guy, my manager, who was older than me, said, look, son, in this country, what you got to remember is the way the economy works is you get what you pay for. If you want better things in life, you pay more. And every time I see these kinds of examples, I'm reminded of my old manager. You're paying less and getting better. It breaks the laws of economics, but it's pretty cool. Here's another example of Amazon.com that we depend on DynamoDB as not the database of last resort as our customers do, but as our database of first choice. Our developers are taught to use Dynamo every single time, except if they must need for certain applications, transaction joins, the relational features that they can't get from DynamoDB. And we would not be able to offer our customers the experience and scale in our online services if it wasn't for DynamoDB. Just give you a quick example. Prime Day that we ran, I think in July, just a few months ago, we were taking traffic prior to Prime Day, which was serving, DynamoDB was serving 6.3 million requests a second, and that's a big number. It's that Amazon kind of scale. But on Prime Day, which was our biggest day for our commerce business, e-commerce business, it had to go from 6.3 million to 12.9 million requests a second. And that went, I didn't even lose sleep. Nobody called me saying, hey, there are problems here, which was beautiful because in the old days, I'd be up all night trying to make sure that much slower rates than that would have to be dealt with. So it's just an example. We have another example where we, as I mentioned, historically we're an Oracle shop, and we still have some legacy applications that are still on Oracle. There was one that we use for running workflows to make sure your packages arrive where they need to go. We run about 4 billion workflows a day, and that number has been going up 2x year over year. And we finally got to a place where we just could not scale that on Oracle and have moved that to Dynamo as well. So just 2 examples of using Dynamo at massive scale that we do. And of course, another customer that I should have mentioned is Snapchat, which uses DynamoDB behind the scenes for their service as an example of another major scale customer. I'll just quickly highlight on ElastiCache, which is a caching and in-memory database service. Is used at scale. It's used a lot of time with databases as a cache. In more and more cases, Redis gets used as an in-memory data store just as a database. It's used a lot. And we launched a graph database, which yesterday was talked about a lot, so I'm not going to spend a lot of time on it. But basically, what's happening is in the connected world, there are lots of use cases which are better served with something which is purpose-built for those connected use cases more so than something like relational, where it gets pretty complicated to serve like recommendations of restaurants, social feeds, retail fraud detection, those kinds of applications. If I was to build this using a relational model, here's the complexity I'll see on one side of the slide. And of course, it's a connected use case, so it's a lot easier and faster to do at scale with a connected database that's designed for that kind of use case. Today, if you are trying to deal with graph use cases, which I was surprised over the last couple of years as we built it, our customers that we worked with, had some really mainstream use cases they were struggling to work with. And they were doing one of the two things, either using relational, which is going to get fairly slow for high-scale queries, or they were using the current generation graph databases, which fall into either open source that are hard to scale because no one has scaled them to the scale that we do, or there are some commercial vendors that have some early implementations which have a better performance and scale, but they're just expensive. And people were not using these and primarily depending on relational. So that's why we introduced yesterday Neptune, which is going into preview. The intent here is to serve these use cases. And here are two customers that are using it in the private beta that we've run for a while. Thomson Reuters, that their customers that are global companies need to deal with tax policies in different parts of the world, and this becomes a connected use case. And then, of course, another one, which I didn't mention here, is Amazon Prime Video uses it quite a bit for the use case where they have customers they're trying to serve and show movie shows and TV shows. In this example for which they're using it, they want to show a customer that's interested in Oscar-nominated movies on their homepage when they come to Amazon Prime. And this becomes, again, connected set of data where it's easier to use something like a graph database. Let me quickly go through our services on the analytics side, and I'll run through them one by one very quickly. They're all listed here just to give you an overview. This is something, again, we started working on analytics back in 2010. At that time, our customers were using traditional data warehouses, Teradata's and Oracles of the world. The use cases were being served with maybe terabytes, single terabytes of databases, or data warehouses, maybe 4 or 5 terabytes used to be a typical case. And the problem that customers were describing to us at that time was that the size of the data is increasing. And because these data warehouses are multi-million-dollar acquisitions of capital for them, where they run POCs and they decide to buy infrastructure that they need, it gets quite expensive. So typical way that this gets sold by the old guard database vendors is they charge you by the amount of data that you want to analyze. And usually is $10,000 per terabyte per year is the industry benchmark on the low end. But systems like Teradata and Oracle can cost you as much as $50,000 a terabyte per year. So what was happening is that because of this reason, people were not analyzing all the data that their system was generating because they had to do an ROI analysis on it to make sure this was data that was worth analyzing and you could get a business benefit from it. And this notion of dark data was coming about where there's a lot of data that is just being thrown on the floor. And that was the world we were coming into, so we designed our first database service and multiple services or data warehouse services with that in mind. And our design principle was we want to not deal with single-digit terabytes. We want to deal with petabytes to start with and be able to go to exabytes as needed. We don't want you to have to write $1 million check to use our system. If you have a 25 cents as the money change in your pocket, you should be able to spin up a data warehouse and see if you want to spend 25 cents more after an hour. And then our whole idea was that you should not have to do an ROI analysis on the data that you have. There should be no dark data. You should be able to put all your data in the system. And we designed it with an intention of it being priced at $1,000 a terabyte per year. And that really resulted in, I'll go quickly to the service that I'm talking about here, which is Redshift. So that resulted in our very first reInvent in 2012. We announced a preview of Amazon Redshift, which we then took into GA in February of 2013, which is designed to be a petabyte scale data warehouse where you shouldn't have to throw away any of your data, and it costs you 1/10. And it's a columnar system, has this architecture that's known as shared nothing architecture. We can start with a single node, and you can spin up to 128 nodes. And with that, you can get up to 2 petabytes of compressed data. We have customers that do as much as 14, 15 petabytes in the system, and we use it a lot at Amazon, and it's something that is a fast-growing service for us. And then we have, in this year, in 2017, April, we launched an extension to Redshift called Redshift Spectrum, which is basically designed to expand the size of the data from petabytes to exabytes. In fact, we did a demo at San Francisco Summit where we ran a single query that had to go through exabytes of data, which, if you're using Presto, will probably take you a few years of waiting to get a response back. And one of the leaders that did this demo was just holding his breath long enough that the system came back. I think he had to hold his breath for a couple of minutes, which was hard, but it wasn't a few years. So the basic idea here is that you're getting to a place where you're dealing with hundreds of petabytes of data in some cases, and some cases exabytes of data, and that's what we want to be able to serve. And when you have that kind of size of data, you got to take compute to storage instead of take storage to compute. So we have an extension layer to Redshift called Spectrum, which is a scale-out multi-tenant layer that we use and scale up based on the size of queries that you're sending to us, which allows us to directly do queries on S3. And some of those features are being launched this time as S3 Select, which other people can use as well. But the basic idea here is it separates compute from storage, also makes it so it can be much more concurrent for a number of users you need, makes it much more elastic, but also allows you to deal with exabytes of data. And here's a customer that's been using it. They are dealing with petabyte scale data. The rate at which their data is coming into their system is so fast that doing an ETL from S3 into Redshift would really not work for them because they want to get access to the data as it comes in, and they directly run queries on Spectrum, using Spectrum and Redshift on S3 to do this. The second service I'll talk about in the analytics case is EMR, which is a managed Hadoop service. If you're familiar with Hadoop and Spark and HBase and Presto and other technologies, we give you a managed version of it. It makes it easier for you to do this analytics. We use S3 as a data lake for it. And I can go into all the details, but the basic idea you get here, it's a managed service. It's significantly cheaper because we use the notion of spot market for these batch-oriented workloads, and you can just specify to us over a period of time, a week or so, that you want to run a certain workload, and we'll go run it at a time of day where we are able to get the cheapest prices from EC2 for the amount of instance size you need and the amount of hardware you need to run your workload, and give it to you at a significantly lower price. Another service that is a fast-growing service for me and for my business is a service called Elasticsearch, which has been around for about 2 years. And it's basically a managed version of Elasticsearch, which is an open source distribution. And people are using it for a number of use cases. Primary use cases, log analytics. And it's something that, in the set of tools that we give you, it's just another tool that's available depending on whether you need to do log analytics, whether you need to do Hadoop, whether you need to do a traditional data warehouse. And another service that we introduced last year at reInvent for another use case that our customers were interested in is this service called Athena, which is basically the idea here is this is completely serverless query service, interactive service. There's no infrastructure to set up. This is basically like what I talked about for, if you will, for Aurora Serverless. The idea here is you're trying to do ad hoc analysis on data that is sitting in S3. You don't do this quite often, so you don't have it set up in the columnar format for something like Redshift or set up for EMR, but you just need to run some queries quickly in an ad hoc fashion on an infrequent basis. And without having to set up any infrastructure, you're able to do it with something like Athena, which is a completely serverless service. You pay by the query. It gets quite a bit cheaper than having an infrastructure set up. So example, again, this is an example of a service which allows you to use for different kinds of use cases. Okay, here's a customer use case. It's a company called Cisco, not the networking company, but the food distribution company. And they have, turns out, massive amounts of data. And they use in the old days or on-premise before they moved to us, the data was coming from multiple sources, including an IBM AS400. And the architecture that they use, in this case, they use multiple different services from us for analytics, is they land all the data into S3. They do ETL on it. And they move it into 3 parts, 3 different systems, Redshift Spectrum, Athena, and EMR. So EMR gets used by the data science team, which is, I think, using notebooks like Zeppelin to do some machine learning workloads using Spark. And so that's the reason why that data goes into EMR. There are a set of reporting use cases and dashboards that they run on a regular basis. They want to get done on a high performance basis. So they've taken that data and put that into the columnar format that something like Redshift needs. And they run those reports on Redshift using Spectrum. And then they have a lot of data that is infrequently used, which is just cataloged in S3. And they are able to run infrequent queries on it as needed on an ad hoc basis using Athena. So this is an example of a customer that is using these services in multiple services in the same use case. And I had mentioned a use case earlier as well with Expedia, where Expedia is using, instead of SQL Server that they used to use for their on-premise use case, they use Redshift for historical analysis, and they use Aurora for their operational workloads. So there's an examples of many customers that are using different services in the same use case. Let me quickly also talk about Quickside, which is a service for business analytics and targeted for business users and non-technical users, if you will, which we launched last year just before reInvent, and it's been out there for about a year. The basic idea here, if you will, from a strategy point of view, just to give you a little bit of color behind the story, is that as we have taken people from using traditional data warehouses like Teradata and Oracle to something like a Redshift or Athena, the cost of storing that data has gone down to obviously 1/10. So you can spin up 160 gigabyte cluster, which is a smaller cluster you can get from us for Redshift single node, for 25 cents an hour. If you want to use old style business analytics tools with it, you probably are talking about spending $100 a user to $200 a user per month before you can access the data that just costs you 25 cents an hour or $1,000 a terabyte. So if you look at it, really the economics don't make sense. And then if you look at the old style BI tools, they require a lot of setup configurations, a lot of work to set up your reports and all that. So it really isn't something that your typical business user like me would use, and we end up falling to tools like Excel, spreadsheets, and those sorts of things to do the analysis. And so that's the target that we thought was underserved, and our customers were asking us for, say, hey, just like you're giving me data warehouses at such a low price to make it self-service, can you do the same thing in the BI layer or on the analytics layer? And we designed a completely serverless service where there is no infrastructure for you to set up. We do all the heavy lifting. You either use a mobile application or use a browser, and we give you a URL to go to. And as soon as you log in, we figure out, based on your login, what are the data sources you have access to. Maybe it's S3, maybe it's S3 plus Redshift, or Dynamo DB, or RDS, or what have you. And we will show you all those data sources, and you can start doing analytics on it right away. We also have an in-memory layer behind the scenes called Spice, which gives you very high performance in-memory kind of performance for a large number of users. And this is a service that we offer at $9 a user per month, so that you can democratize access to all your data for all your employees, so that everybody can benefit from access to data. And what we have seen since this service came out is that service, in fact, this has happened over the last year or so, as Lambda has become very popular. People love the idea of doing things serverless because there's nothing to set up. And the use case that we are seeing with Quickside, which is pretty unique, is that people are not even using a data warehouse, if you will. They take the data that is coming from source, maybe it's an Aurora, maybe it's an RDS, it might even be in Redshift, and they spin that data on a regular basis, take a snapshot of that, which they want people to analyze, and put that data set into S3. And they run Quickside, which is completely serverless. They use Athena behind the scene, which Quickside is integrated with. So when you make a query, we go spin up Athena behind the scene, and we go query the data sitting in S3. And you can do it for tens of thousands of users without the cost or complexity that has traditionally been associated with using BI tools or data analytics or data warehouses. So it's a very novel way that people are doing it. People are also using it with Redshift. They're also using it with other data sources, Aurora and RDS being the second, third sources. And there are a number of different ways this is getting used. And people are doing historical analysis. They're doing real-time processing in dashboards, and more doing predictions and other kinds of features with it. OK, let me just quickly now run through. I have a few minutes. I'll just take 30 seconds to highlight some of the machine learning services my teams are doing, which have relevance when it comes to your data, your own data sitting in your data warehouses, S3, and other sources. Quickside is one way to get insights out of it. But machine learning, as you probably heard yesterday and throughout the day if you went to those sessions, is all about making sense out of data that you own, because machine learning without access to data is kind of useless. And your data is sitting in these data stores that I just talked about. So we launched yesterday a service called SageMaker, which is a way for you to do your own machine learning algorithms and models and so on from your data science team, but do it on your own data, which is sitting in Redshift and other cases. And it's the quickest and easiest way for machine scientists to make sense out of their own data that their company has for things like fraud detection, recommendation systems, and other kinds of things where they need to work with their own data. And the final one that I will mention is this service called Comprehend, which is what is known in the machine learning world as a natural language processing system. All it does is it looks at, on a very simplistic way, it looks at text and tries to make sense out of it. It will tell you things like, what are the entities? Is there a city or a place mentioned in it? Is there a product name that is mentioned in it? Is there a name of a person that is mentioned in it? What's the sentiment that is with it? Is the person happy or the person unhappy? And you can use this to analyze, customer reviews and those kinds of things, your customer data, et cetera. Turns out all that data is your data, which is sitting in your data warehouses or your data stores, S3, et cetera. And this is another way that you can analyze and get sense out of that data. So if you think about it, we give you all of different tools to store your data, to serve different broad use cases, and give you tools to serve all users. So if you were to remember just 3 things from this conversation, it would be, we would serve all your use cases, so you should bring all your databases to AWS. And the more you use our managed services, the more sleep you'll get, the happier you're going to be because of all the work we do for high availability and performance. The second thing I would say is that you shouldn't have to do anything about ROI analysis on data. All data has value, and you should be able to store it in S3, Glacier, Redshift, et cetera. And the third is all your employees and users deserve to have access to the data so that they can be more effective and more efficient. And you can use services like Quickside, SageMaker, Comprehend, and others to, in a cost-effective manner, give access to people. And the last thing I would say and would end with is lots of services here. So here's a roadmap on how to think about it. If you're bringing existing applications from on-premise, chances are they're relational database workloads, and you may not necessarily want to completely go to NoSQL, although many of our customers do that. And if you are using MySQL or Postgres, obviously go first to Aurora, and if you choose to, you can also use the RDS MySQL and Postgres version. If you're starting from Oracle SQL Server, your choice to make. We will serve you any which way you like, but our highly recommended approach is to move that data to Aurora because you'll get much better cost and performance profile. But if you want to, you can use RDS, Oracle, SQL Server as well. If you're writing new applications, my personal recommendation is always start with Dynamo. If you need in an application to use transactions, joins, other must-have relational features, then go to relational because you'll get a much more highly available, highly performant, highly scalable system. In memory, you should use cache for data warehouses. Depending on the workload, use Redshift for a traditional data warehouse. Use Spectrum if you have a need for high scale, and use Quickside with it. If you're doing interactive analysis, ad hoc basis, use Athena and Quickside. If you're running your data science team and others need to run Hadoop workloads to EMR for log analytics to Elasticsearch. And of course, machine learning is SageMaker or EMR with Spark. And natural language processing of your data is through Comprehend. And with that, I have 0 seconds left. Thank you.